Okay, everyone, we're back. This time we're outside in this lovely garden, and we're gonna carry on with our move learning. One thing I forgot to mention last time was that all of the code for each of those episodes is linked in the description, the finished code, so you can refer to that and follow along if something is not working. So let's continue building our module, our social network module. So first of all, we talked about this struct that has this ability drop. I'm going to give it a few more abilities. It's going to have store and key. And this means that this person is going to be able, this struct will have the capability to be stored in something called global storage, which moves paradigm for storage on chain, which is quite a large topic, also quite specific to move, and something that we won't go into deeply right now. We'll just keep coding. So the other thing we're going to import here is this primitive type vector from the standard library, which allows us to create vectors containing any type. So here we go. We're going to make a struct and we're going to call it friends. And friends is also going to have store, key, and drop. And inside friends, we're going to have this field called people. And people is going to be a vector of types. What is going to be inside, what is the type of each element in this vector is going to be a vector of person. So basically this field of people is each element inside this vector is going to contain one person. So basically now we're going to do something here. We're going to add a new public function. So this public function, because it's public, can be called by anyone. It's going to be called create friend, and create friend is going to take in my friend. And actually, let's just call this friends, keep it simpler. And friend is going to take in a type of person, and it's also going to take in something else, friends, which is going to be of type reference to mutable friends. Okay, and it's going to return the person that we created. All right, so what did we do here? What is this reference to mutable? So similar to Rust, we have this mut keyword mutable, which means that we can change the thing via the reference. If we don't have this keyword mut, it means that the thing is immutable, meaning we cannot alter it. It is immutable. So we're getting the reference to friends, and we're saying that this reference is a mutable reference. So basically, this friends that we're going to pass in, this struct, we want to alter it or modify it somehow. So let's actually write the body of the function now. So let new friend equal person. We're going to create a new thing here. Name is going to be, yes, we haven't got a name field here, so let's add it here. Name. What is the type of this name? It's going to be a vector. U8. So is going to be friend.name. Age is going to be friend.age. So So this friend that we pass in will have an age and a name on it, and we're assigning that to this variable new friend. And then we're going to have a function here called add friend, and add friend is going to take in this new friend, and it's also going to take in the friends. Ooh, what was that? So we need to write this function add friend. So it's going to call this other function public function add friend, and add friend is going to take in person, and that's going to be of type person. And also, as we know, it will take in friends, which is of type reference to mutable friends, and it will return nothing. Absolutely fine for it to return nothing. So what's it going to do? Well, we want to update this struct and this people field with the new friend. That's essentially what we want to do. So the way that we push to a vector in move is we use this method on the vector called vector pushback. And pushback takes in two things, and this is why we always needed the mutable friends around. It takes in the original vector, which is mutable friends dot people, right? Because that's the field there. And then the new thing that we want to add on, person. So this is how we push to an array or a vector to a vector in move. Pretty cool. So this is going to add it, and then if that's all successful, we're going to return new friend, right? So we're gonna call this function push and then return so that we get this back. I mean, sure, we could have just put this in here, but I thought just to break it up to show that we can call another function in here and just have this as a one line and just have this as add friend, perhaps makes this function more readable. We could have easily put this vector in here, but I'm just sort of playing around, showing you different paradigms here. So cool. So that's it, really. That's the bulk of our code here. I'm going to remove this setAge function because we're not going to use it actually right now anymore. So just for clarity, let's just move it, and let's also move this function. Yeah, need that test function. Okay, we're going to write some new unit tests to test out our code. So I'm going to just create a kind of dummy bit of data here for testing. So I'm going to create this variable called Richards, which is going to be of type person, and it's going to have a name, which, just follow me here, and I'll explain what we're doing after. Age 31, unfortunately. Okay, so what is this here? This name B Richard. Okay, so we have this thing called, this variable called Richard, and it's of type person. Well, person has two fields, a vector of name, a field of name, and a field of age. Name is of type vector U8. Age is of type U8. So this is how we represent strings at the native level of move, without using any frameworks, without using any, this is like the native way of using strings. So the way strings are actually represented is inside a vector of U8s. And this might seem weird to you, but when we use this syntax B and then put the string in, this turns it into a byte encoded vector of Richard. So to just make this point clearer, let's have a look at the documentation. And let's just do strings, vector literals. So we have here a byte string. Let me take out the vector 8 literals. A common use case for vectors in move is to represent byte arrays, which are represented with vector U8. There are currently two supported types of vector U8 literals, byte strings and hex strings. Byte strings are quoted string literals prefixed by a B. So that's what we used, the byte string. And we can add in escape sequence characters, new line carriage return tabs, and then hex strings are quoted with the X, and each byte pair ranging from 00 to FF is interpreted as hex encoded U8 value. So this is how we work with strings at the native level on Move, on chain. So that's that, and now we're going to create this thing called friends, which is going to be this friend struct, and we're just going to say people is of type, well, what is it? It's of type vector of persons, right? Vector's a vector of person. So here we're going to write vector and Richard. So this is going to actually create an inline vector literal, and we're going to populate it with this variable Richard. So by putting it in brackets in this field, we actually create this vector in place, and we assign it to the variable friend. So we need all this data here to be able to run our test. So now we're going to actually call the create friend function. So what do we need in create friend? We need a friend and we need friends. Friend is of type person and friends is of type reference to mutable friend struct. So for friend, we're simply going to add in Richard, and for friends, this is actually going to be friends. So this is going to be a reference to mutable friends. So we basically need it to be this reference to mutable value because that's the type that it's asking for. If we don't add that type, this function will not work. Now we're going to add in our assert. So the assert we use in our tests to assert that the test passed or failed. So the way that we do that is we write assert, and this is, so we say created friend dot name is going to equal, well, we want to check that it equals B and Richard, right? And if it fails, we want to abort with the code 0. So that's the second parameter, the abort code. So what are we doing here? We've got this Richard, we've got this friends vector, and then we're calling create friend. We're saying create the friend Richard, and it should return with this created friend, right? Create, return new friend. And if created friend dot name equals this value here, then we know it's happened correctly. So let's try it. Move test. So unexpected, expected a type ability, one of copy, drop, store, or key. So that's just a simple typo here. I believe that's all. Unexpected friend, create friend, unexpected an identifier. So that's on line 4. Oh, I know why. Probably not the best example to use the word friend, because friend is actually a keyword in Move, which we'll get onto later on. So we can't use that word because it's a reserved keyword. Probably not the best example, but it came out of this whole social network thing, friends. but we actually use the keyword friend to do something in move, which I will show you later on. So I just changed this to my friend, which is not a keyword. Move test. And expected, oh, we missed something here. Could it be this? Unexpected add friend, line 20. We are missing semicolon, and we're going to miss semicolon there. And the same 14. I always forget these. 14, 4. Invalid usage of a previously moved variable, Richard. The value of Richard was previously moved here. Suggestion, use copy Richard to avoid. So what is this? This is an interesting error. The value of Richard was previously moved here. Suggestion, use copy Richard to avoid the move. So basically what it's saying is that this Richard has to have another ability. The struct of Richard, which is of type person, has to have another ability for me to actually just assign this into friends and essentially copy the value of this variable into this value friends. And why is Move so pedantic about this? It's because it wants to ensure safe resource positioning, if you like, in the blockchain, so that if none of these abilities are used, then it's very difficult to accidentally copy an NFT or any kind of struct. So I need to explicitly say copy. So struct person, it has these abilities. It has store, which means we can store it in global storage. It has key, which means it can be indexed on global storage. It has drop, which means we can delete it. And it has copy, which means we can copy it. So it's basically saying this struct is not valuable at all. We just want to be able to do a bunch of stuff with it. We need to explicitly say, yes, let us do it. Let us do this stuff. So that's actually quite a good one. Unused use of debug, correct. We are not using debug at all. So let's just get rid of it. And let's run it again. Awesome. So we're passing our tests. So total tests 1, passed 1, failed 0. So that means that this created friend.name is equaling Richard. For example, let's say we change this to another name like Luke, move test. Now it failed because this Richard is actually being created with created friend has the value of .name Richard, not Luke. So we can safely assume that our code is working correctly. So we went through quite a lot there. We went through vectors, we went through more abilities, we used the assert method inside tests. We also saw how to do some cool syntax with vectors here, and we touched on mutable references. So yeah, that was quite fun, and let's go on to our next one.